Let's look at a typical problem for calculating a pH. So this question is asking us to find the concentrations of nicotinic acid, hydrogen ion, and nicotinate ion in a solution of 0.1 molar, and then this is the formula for nicotinic acid. It's asking for the pH, and it gives us the Ka. So you need to recognize that this acid is not on your list of strong acids. Therefore, you need to make an ICE table. So start with the formula of the weak acid, and then notice that typically what we do is we put the acidic hydrogen first. So this is the acidic hydrogen, and these other hydrogens are not acidic. So then you're going to want to draw your equilibrium arrows, and you will break up your weak acid and write your ICE, your initial, your change, your equilibrium. Then you need to fill in your table. So we have the H plus, the anion, and we start with the molarity of our weak acid as our initial. We have 0 of the hydrogen ion. We have 0 of the anion. So it's going to be minus X plus X plus X. Then we follow down, and we have for our equilibrium 0.10 minus X, X, and X. We set up our Ka expression, which would be products over reactants. So this X times this X will give us the X squared. And then our equilibrium for the weak acid will give us what goes on the bottom here. We're going to assume that this X is small, and so we can simplify to get this. Now all we have to do is solve for the X squared. Remember, this value for Ka was given. So when we do that, we end up getting X is 1.18 times 10 to the minus 3. We're going to check and see if the 5% rule applies. We're going to compare X to the initial molarity. So that's how we get this. 1.18 times 10 to the minus 3 over 0.1 times 100%. That gives us 1.18%. This is much less than 5%. That means that our 5% rule applies and we're okay. We look at our table, and X is our hydrogen ion concentration. It's also our anion concentration. So we have the answer to both of those. That's here. And then we take the X and subtract it from 0.1. It's so small that we end up getting approximately the same answer. The question asked for pH. And so since X was our hydrogen ion concentration, we put that in our formula for pH. And we solve for pH. You might also be asked to calculate a degree of ionization. A degree of ionization is like percent, but just don't multiply by 100%. So you take the X, put it over the molarity, and then you get the value. So it's set up similar to how you would calculate percent, but remember, do not multiply by 100%. Okay, let's do another problem. So again, you need to recognize that the acid given is a weak acid. This is nitrous acid. We're given the Ka and we're asked to calculate the pH. So you're going to want to set up your expression. So we have the weak acid in equilibrium, and we set it up in an ice table, which ended up not being on the same page. And sometimes you will have to use the quadratic formula. So if you have to use the quadratic formula that is given here, let's look at how your ice table is set up. So here is your weak acid. You break it up into H plus and nitrite. Initially, we have 0.036 molarity of the weak acid. We have 0 of the hydrogen ion, 0 of the nitrite. It's going to be minus X plus X plus X. And then we follow through and get our equilibrium row. And then be prepared to use the quadratic equation. And the way that you would know to use the quadratic equation is at first, you would go ahead and assume X is small. And then you would use just the regular setup to solve for X. When you solve for X, you always want to check to see if the 5% rule applies. So when you would assume X is small and just use this to solve for X, you would find in this case that X is larger than 5%. So the 5% rule does not apply. When you determine that the 5% rule does not apply, then you will have to use the quadratic formula. When you use the quadratic formula, remember that molarities must be positive. So you want to have a positive molarity. And your X cannot be greater than this initial molarity that you started with. So in this case, when you use the quadratic formula, you end up solving for X, which is our hydrogen ion concentration. You put that in the pH formula and you get the pH. So be prepared to use the quadratic formula.